Thanks a ton. Well, unlike a lot of my fellows here tonight, I'm actually just an undergrad. And as you guys may remember, undergrad was a really fun time. However, towards the end, we're faced with a pretty big dilemma. We don't necessarily know what we want to do. And I'm currently asking myself, do I want to be a mathematician, chemist, biologist, astronomer? Do I want to play in between? Do I want to become a computational chemist or an astrobiologist or a biochemist? But if there's one thing I've learned from Titan, and I'm going to let you guys know tonight, it's a little secret. In a few years from now, in the near future, given the problems we'll be facing, it really won't matter. So Titan is a moon of Saturn that is really catching the interest of an innumerable amount of scientists. Pretty much any sort of scientist you know of is probably interested in Titan. So scientists and engineers a few decades ago got together at NASA and decided that they were going to send an orbiter and a lander to start recompile data on its atmospheric constituents, understand its surface chemistry, and since then we've had questions in geology raised. Are there cryovolcanoes? Are there active tectonics occurring on the surface of Titan? That would be volcanoes erupting at very low temperatures, emitting liquid and vaporous forms of ammonia, water, methane. It's not exactly a cow fart, is it? But on methane, we've also discovered that on Titan we can see solid, liquid, and gaseous forms of methane, forming a sort of hydraulic cycle. Given the importance of water and its hydraulic cycle and how that implicates itself on the importance of life on Earth, we are also asking questions in terms of how can this hydraulic cycle teach us things about how life works on Titan, if there is. So how do we know it's even possible? Well, there's my research. Given the fact that we have these prebiotic molecules, I'm characterizing the reactions to see if it's possible, if these reactions are feasible in terms of the temperature and pressure on Titan to produce, for example, amino acids, the building blocks of proteins. There's calculation, there's chemistry, there's even a bit of astrobiology in there. So, how is this really helping? Well, what I'm thinking, this is Titan, and the big problems we'll face tomorrow really have no bound in discipline. No one really cares if you're a chemist, mathematician, biologist. They just really want to know that you're there, you have the tools, and we're going to solve the problem. Thank you very much.
So you mentioned the possibility that there might actually be life on Titan, and then you mentioned that you're studying the possibility that there's amino acids and what the amino acids might be doing there, which sounds like something that, at least on Earth, we're used to that leading towards life.
Right.
But in order for amino acids to do what they do here, don't they need to be in liquid water?
Right.
And so how would that work on Titan?
Right. So the key question, you basically gave the answer in your question, is that the life we're used to. Right. So sometimes we have to break those paradigms, and I think we're going to be hearing a bit on that later on, in terms of what we understand as life and how life will function. The fact that there is a hydraulic cycle offers a sort of dynamism. There's action occurring on the surface. And the fact that, even though it's not water, methane has these dynamic properties and allows the movements it allows, though it doesn't have those, for example, hydrogen bonds, water might form and are important in their interactions with amino acids. They do offer a dynamism that has us questioning the possibility.
So if I'm understanding you correctly, you're saying it's going to take an interdisciplinary team to do this, to figure all this out. And I'm looking at some of the things that have been put together, like cosmobiologists, astrobiologists, climate scientists, computational chemistry, physics. So there's a whole lot of things. What would be the perfect name for the scientist who does, who's going to do this? What would be the perfect job description title for that all-around scientist who's going to figure this out?
So, as you mentioned, we have a bunch of titles going around, and all of them really are, we don't just need interdisciplinary teams, we need interdisciplinary scientists that know enough to recognize the problems, and if they don't know how to do it and they don't have those techniques, they know who to call. But the fact of the matter is that as we move forward, we're going to start incorporating and acquiring more techniques that are going to just be scientists. We'll just be problem solvers instead of just scientists. And yeah, it'll be based on the techniques we'll need tomorrow, and I'm sure they all have quite a few.
I like that job title.
Problem solvers.
So, Sean set you up talking about modeling and climates and things like that, and then you came out and said that you're a computational chemist.
Right.
So when you're talking about prebiotic molecules and amino acids and methane falls on Titan, this is not like wet chemistry. You're doing this all in silico. Can you tell us a little bit about that process?
Yeah, so I work on the kinetics of these reactions. So I set up basically what I believe, or not what I believe, what we've observed through spectroscopy, through these landers and these orbiters that we've sent in that direction. What are the molecules that I have as reactants? And given the pressure, given the temperature, given the distinct atmosphere it'll be in, I can start to predict how these will move using quantum chemistry, right? So this offers me a framework in which I can compute how these reactants will eventually evolve and what products can potentially be formed. They can react in very different forms than what they would react on Earth because of these different conditions. So working out a model that takes in these parameters and allows to adjust for those conditions that may very well be different from the Earth, may be different from Venus, then that's how we end up modeling and understanding what could be with these reactions.
Cool. Just so long as you wear a lab coat when you do it.
Thank you very much.
Thanks, Dan.